Welcome Neil Jacobstein.
Thanks, Will.
Thank you, Neil.
Hi, everyone. It's a great pleasure to see all of you here today. A lot has been happening with AI in 2019. Let's get started. So what's changed? Faster specialized hardware, better machine learning algorithms, more, not just big data, but relevant data. And something that has really changed recently is money and money driven by results. For example, on July 22nd of this year, Microsoft invested $1 billion in OpenAI to create an AI tech platform of unprecedented scale. What does that mean? They're recognizing that hardware and scale really matters for problem solving. And then 4 days later, SoftBank announced a $108 billion AI vision fund. The scale of that is almost unbelievable. It's unprecedented in the AI world. And it's not just money driving things in AI today. The AI community is now charged up about making a dent in grand challenge problems like climate change. Here's an article that came out in June of this year with 22 authors from 13 top institutions, all about tackling climate change with machine learning. And it's a substantive set of considerations. Look at this: electricity, transportation, buildings and cities, industry, farms and forests, CO2 removal, climate prediction, societal impact, solar geoengineering, tools for individuals, tools for society, education, and finance. There are chapters in their report on each one of these things. It's not just a breezy report. So you can expect to see machine learning used to really impact climate change. Hardware has been a big driver lately. Here's the NVIDIA Tesla. The V100 processor has 21 billion transistors. And just yesterday, when we started this conference, a company called Cerebras announced a wafer scale engine that is 22 centimeters by 22 centimeters, 1.2 trillion transistors. It has 56 times the surface area of the NVIDIA Tesla chip. And if you are interested in empowering your teams with AI, I wouldn't recommend starting with chips and racks. I would recommend starting with the cloud, because that gives you access to scalable hardware and software frameworks that can greatly accelerate your problem solving. So here's Google Cloud's Anthos, which allows you to migrate your solutions from the Google Cloud to other cloud services as well, like AWS from Amazon or IBM Watson. So what we're seeing is that you can get started right away and not have the friction that's built into designing all of your own frameworks and your racks for computing. Things are now moving so fast that it's almost a blur, where you need augmentation in order to resolve the speed of events. The competitive advantages from AI and machine learning are all of these. I'm not going to read them to you. The most important thing is expanding the range of the possible. What are these competitive advantages? You can reframe them as skills that you can take on yourself or that you can gift to your organization or your corporation. Expanding the range of the possible, doing things that you didn't know that you could do before. At Stanford, we've been looking at some decision metrics for improving decision making. Again, I'm not going to read these to you, but I'll just pull out one. Less error and bias. If you have the ability to identify what your assumptions are, you can test your assumptions. And that really matters. When your assumptions break, your problem solving breaks. All of you know that deep learning is a subset of machine learning, which is a subset of AI. Gary Marcus did a critique of deep learning. As successful as it is, it still has some weaknesses. And I'll just pull out a few of them. It's still data hungry. It's still shallow with limited ability to transfer into other skills, although there's been some success at that. It's not sufficiently transparent. You can translate that to it doesn't do explanation very well. And it cannot inherently distinguish between correlation and causation. And you may know that humans have some difficulty with that as well. One thing that Gary didn't identify in the set of weaknesses is this one. AI lacks empathy. Now, that doesn't matter too much when you're identifying cat videos, but it does matter in medicine. It does matter when people are expecting empathy and they don't get it. So Dave Gunning at DARPA is running a program called XAI to improve explanation from machine learning. That really matters. He's working with 12 teams. They're getting some good results. Not all the results involve explanation using language. Sometimes the explanation is just pointing to a part of an image that has a problem, like a carotid artery. And we also know that machine learning can do descriptive analytics well, and it can do predictive analytics well, but prescriptive analytics, deciding what should we make happen, is still difficult. People can do this fairly well in an emergency or in an epidemic, but machine learning is not so good at this yet. So far, we haven't even come up to the bar, which is a pretty high bar, of a human 5-year-old. In spite of that, machine learning can do some pretty amazing things. DeepMind's AlphaZero, which trains itself to do a variety of different tasks from scratch, has been able to master multiple games: chess, Japanese shogi, and Go. Check this out. Just with a couple of training steps on the order of 200,000, it can beat Stockfish, a champion chess player. It learned chess in 8 hours. Shogi in about, again, 180,000 training steps. And AlphaGo, it surpassed Lee Sedol at about 100,000 training steps, and the world master Keijai at 400,000 steps. DeepMind also created a system called AlphaStar, which beat 2 human pros at StarCraft 2, an epically complex game that involves multiple iterations over time. And the people that were observing this competition had the following to say. AlphaStar split its stalkers into squads and flanked Nama's army on multiple sides. He was dumbfounded. What we saw there, that's not human. Well, they got that right. We are now driving our intelligence past just manipulating bits and information into manipulating atoms and molecules and matter, and navigating complex terrain with robotics. Yesterday, you saw an early example of the Atlas robot. I believe that was from 2016. Here's the Atlas robot from Boston Dynamics in 2018. Many of you have seen this with parkour. The evolution of this capability is really amazing, very fast evolution. In the spirit of full disclosure, this Atlas robot sometimes crashed on this task, and they cherry-picked these. So I think it's important to understand where we actually are today. You get the idea. Science Robotics has been reporting on advances in robotics for the last 3 years. This particular issue was on robots for space and marine sciences. What's happening with marine sciences? We've got robots swimming underneath glaciers and using AI pattern recognition criteria to decide when to take a picture of melting glaciers. And when we send our robots to Mars, it's not just cool, we're doing real work there. This is the Curiosity robot that drilled a hole in the Gale crater and discovered an organic molecule there in June of 2018, thiophene C4H4S sulfur. An organic molecule, maybe it was not created by life, probably not, probably created by inorganic means, but still an amazing discovery on a planet far from our own. And here is a smaller robot. How small? 25 microns, 25 millionths of a meter per side of this triangular flap. It moves around on this platform by flapping its triangular sides. The platform that it's on is a cross-section of a human hair. In January of 2018, the Technical University of Munich published an article in Science on a self-assembled nanoscale robotic arm controlled by electric fields. What is that electric field control about? You've got this 25 nanometer DNA arm. It is amazingly small. Remember, a nanometer is a billionth of a meter. And you can pulse it in 360 degrees by positive and negative electromagnetic fields. It doesn't do a lot of work on its own, but when you gang them together, like actin myosin, you can get a lot of work done. Let's talk about some application areas. One of the most important applications of AI in 2019 is reinventing the way we invent. And an example of that is from In Silico, a pharmaceutical company that's using generative adversarial networks, generating drug candidates, and evaluating them using a discriminator to see if they come up to the bar of molecular properties that we're looking for. Philips Electronics has been monitoring instruments in the intensive care units for years now,